Hello, thanks everyone. Thanks for joining. This event is brought to you by DataTalks.Club, which is a community of people who love data. We host weekly events, and this event is one of them. So you can find out more about events if you go to our website, datatalks.club/events, and you'll see that we have two types of events. So today we have a webinar, which is a technical talk with a presentation with question afterwards. And then on Friday, we have a live podcast. It's more like an interview, more casual. So this Friday, we will talk about effective communication with business for data. So if you're interested in this stuff, check it out. And this is how you can find information about our events. Then to stay up to date with everything that happens in our community, you can subscribe to our newsletter, join our Slack, and subscribe to our YouTube channel. And last, today, during our presentation, you can ask any question. For that, in the live chat, you have a link to Slido. Click on this link and ask any question. If you see a question that was already asked and you liked, you can upload this question, and questions we will start with questions that have more upvotes. And that is all from me. And Josh, the floor is yours.
Great. Let's see. Am I able to share here? Okay. Oops, giving away all of my. All right, thanks so much. I'm Josh Tobin. My background is in machine learning research. I spent a few years at OpenAI doing research on deep learning and robotics. Did my PhD on similar stuff at UC Berkeley with Peter Abiel. And I guess the more relevant piece of my background to what I'm going to talk about today is I also co-created this course with Peter and with Sergey Karyev called Full Stack Deep Learning, which the goal of which is really to teach about everything that you need to know about making machine learning work in the real world, other than how to train models and how to use TensorFlow and things like that. And so we cover things like scoping projects and troubleshooting when things go wrong, and infrastructure and deployment and monitoring and testing and managing teams and things like that. And so that course kind of got me really interested in the world of machine learning infrastructure, which is what I want to talk to you about today. And so the talk is going to be in three parts. First, I want to give my view of where we are heading as a field in machine learning. And then I'm going to take a look at the machine learning infrastructure stack and ask the question of, is this keeping up with where the machine learning field is heading? And then finally, I'm going to propose a concept that I think is missing from the ML infrastructure stack that could help address maybe a lot of what's hard about production machine learning currently. So first, my view of where we're going as a field of machine learning. So I think, just to get straight to the point, that machine learning is quickly becoming a product engineering discipline. And it's not just me saying this. We're in good hands here. If you believe this, Elon Musk agrees with us, so that's good. And next thing I want to do to put this in a little bit of context is just to tell the story of kind of how we got here in machine learning industry. So machine learning being used in the industry is not a new thing, even though many of us who got into the field recently feel like it is. ML in industry has been used for a long time. Early on, the way I would characterize the usage of ML in industry was what I would call like ML as analytics. So machine learning models were being trained offline on relatively small data sets, and they're being used to produce predictions about things that would then be an input to a decision that you as a business leader would make. So maybe let's predict where we should put the next McDonald's or something like that. Then in the 2010s, something big happened in the world of machine learning, and that was deep learning and reinforcement learning and all of the hype around machine learning that we all have seen. And in this era, a lot of teams, a lot of companies invested in doing machine learning without really having a fundamental understanding of how this is actually going to make their business better. There was a lot of chasing machine learning because people thought it was the thing to do. And charitably, I would say that the value that companies were getting out of machine learning in this era was from the marketing potential of it, right? So being able to say that you're doing exciting machine learning work, being able to say that you're doing all this high-profile research was a good way to attract talents and to maybe attract investors to your business. Where I think we're kind of quickly reaching as a field, though, is an era where machine learning teams are going to be judged by the same criteria that every other team in the company is judged by, right? Which is, does this machine learning effort, does it make our business better? Does it make our product better? Does it make our company better? And I think the characteristics that we'll see starting to emerge are, teams valuing reproducibility and scalability over necessarily having the most state-of-the-art and the most complex thing. And I hope the value that companies will get from machine learning will be from models that actually improve the company's products or services. Now, for those of us that started working in machine learning in kind of the ML hype era, or came more from the research area, or work on a team that is not actually generating business value yet, this presents a pretty big challenge. And I think the core reason why this transition presents a challenge is that to go from writing machine learning papers or doing machine learning as analytics to building these machine learning driven products requires a fundamentally different process than building machine learning in a vacuum. So this is how I would characterize the process of building machine learning models, say in academia or in an environment where you don't need to productionize the models. So you pick a problem to work on, you collect some data, you clean that data, you label that data, you train model on that data, and you iterate on training models, right? So you're training better and better models that are a better and better fit for that data set that you collected. And then at the end, the result that you produce is a report. So a paper, a dashboard, a chart of some kind. And I would call this kind of way of looking at the life cycle of building a machine learning model flat earth machine learning. And the reason why is I think, it's kind of like thinking the earth is flat, right? Like just because you can't see that there's an outer loop surrounding everything that's visible to you doesn't mean that it doesn't exist. And the way that I would characterize the difference in process that you need if you want to build machine learning enabled products is it adds this outer loop, right? So once you've trained a model and you think that model is good enough, then instead of just reporting it and being done, you need to test that model. And when the model is tested, you need to deploy it. You need to monitor it when it's in production, make sure that performance doesn't degrade. And then ultimately what makes these products really powerful is if you can close the loop by collecting the data that's going through the model, re-cleaning, relabeling that data, and then ultimately retraining your model on the data that you collected. And so once this is done well, this creates a data flywheel, right? Where you collect more and more data that allows you to build better and better models. Your better models make your product better, which helps you get more users. As you get more users, you get more data, which allows you to close the loop and improve your models over time. So this is kind of what I see as the goal of the process of building production machine learning systems. So the next question I want to ask is, I want to kind of take you through a tour of a lot of the stuff that's happening in the machine learning infrastructure landscape and kind of try to ask the question of, are the tools that we have keeping up with this new process, or where might there be gaps? So let's start by looking at the training part of the process. There's a couple of categories of tools that have been emerging to help with sort of modern machine learning training workloads. So you have your training infrastructure, helps you run training jobs and hyperparameter sweeps at scale. And then as you productionize your machine learning systems, in many cases, you end up running more and more experiments. Those experiments become hard to keep track of. And so there's a whole category of software that's emerging to help track the experiments that you're running in the training phase. And then finally, when you're in this paradigm of retraining your models pretty frequently, it becomes very important to be able to reproduce training runs that you did in the past. And so there's another category that's emerging around producing reproducible machine learning pipelines. And so I would say actually the training part of the process is pretty well covered by existing tools. I think the tools here that we have here aren't perfect, but I think they are starting to get quite good. And so I don't really see any major gaps here. All right, so let's look at testing next. There's one category of tools that I would call like model performance exploration. I think the what if tool from Google is maybe the main example here. Something like weights and biases has some features that help with this. And these tools are really aimed at helping you understand at a granular level what's actually going on with your model, as opposed to just looking at accuracy. Let's dive deeper and understand how that accuracy is working across different slices. There's another category called explainability tools that are aiming to help you understand why the model made predictions that it made. So this is another way that you can test to make sure that your models are performing as well as you expect them to perform. And then the traditional, in terms of operationalizing these tests, the traditional CI/CD tools do a pretty good job here, but maybe don't do exactly what you'd want for a machine learning tool. But there's a couple of things here that I still think are really hard. So, when you're looking at the accuracy of your model in kind of the offline like machine learning research world, it's okay to have a single metric that you look at, like accuracy, and then try to drive that metric below some threshold. And then, if your accuracy gets better than state of the art, then you're done. You write the paper and, you finish your PhD and you graduate and everything's good. But in the real world, it's super important to look at these single performance numbers and try to actually understand what are the components of my data set and how do those relate to the performance. And in particular, it's very, very common to have high aggregate performance numbers that mask problems in important subsets of your data. And servicing those areas of poor performance is still a really difficult challenge for most teams that I talk to. And then, a bit of a longer term concern, I think as you expand the testing that you do on your models, the natural thing that happens is you accumulate all of these data sets, all these test cases for your model. So, you encounter some edge case and you fix that edge case, but you want to keep a data set around to make sure that when you train a future version of the model, it's not subject to the same problem that you had in the past. And so these test cases tend to accumulate, and there aren't really good tools right now for teams to manage those test cases and keep track of them over time. Let's look at the deployment part of the stack next. So there's tools that help with actually serving models in production, just routing traffic to the models, making sure that they're returning responses in an efficient way. And then there's another category of tools that is becoming very popular recently called feature stores, which I put in the deployment category because I think one of the kind of main benefits of feature stores is that they help make the features that you define offline available to your models online. There's other benefits as well. That's, I think, I see as sort of the core benefit. But there's a couple of things that are still challenging for a lot of teams to do in the deployment phase of model creation. So one of those things is experimentation, right? In machine learning, I think, let's say in DevOps in general, there's sort of a growing trend toward thinking of, as we build more and more complex systems, thinking of testing in production as being something that is not a crazy thing to do, but actually a mandatory part of the process of creating these complex systems. Because as your system gets more and more complex, it becomes more and more difficult to think of every possible thing that could go wrong before you deploy it. And in machine learning, I think this is doubly true, right? It's extremely difficult to exhaustively test your models before you deploy them. And so having some sort of mechanism for testing in production, right? So for running a shadow test or an A/B test is extremely important in the ML world. And it's still something that I think very few teams have a good answer to. And then another challenge in this part of the stack that has sort of plagued machine learning teams for a long time is consistency between the offline world and the online world. So in machine learning, in many cases, the folks that build the models are not the same people that deploy them. And so and even if there might be a translation step where you take your model that you built in a notebook and scikit-learn and translate it into say the Java stack that your production team wants you to use. And that translation step can lead to inconsistencies, which can cause really nasty model performance problems. And so this is kind of one of the benefits of a tool like a feature store, but I think it's still not really a solved problem for the way that most teams deploy their machine learning systems. Once you've deployed, now it's time to monitor your models and make sure that the performance doesn't degrade when it's in production. A few categories of tools exist here. So there's some open source libraries that are focused on helping you measure data quality and detect data drift. There's one from Amazon called DQ, one from Google called TensorFlow Extended, and then there's a open source library event kind of startup open source tool called Great Expectations that's growing in popularity recently. And then you have system monitoring tools, the classic APM stack. But I think this is kind of far from a solved problem. So one thing that's still really difficult is performance monitoring. So in a perfect world, right, you would actually have access to, you'd be able to measure the accuracy of your models in close to real time. And in the real world, that's extremely difficult, largely because we don't always have access to labels in real time, but also because there's some difficult infrastructure problems involved in connecting feedback from model performance back to the original predictions that the model made. And this becomes particularly difficult when the feedback that you're getting about your model performance is something like a business metric that maybe isn't perfectly correlated with your model's predictions. And then again, in a perfect world, we would be looking at model performance metrics, but in the real world, we don't always have access to them. And so it's important to also measure the distribution of data that's coming into your model and the distribution of predictions that your model is producing so that you can detect problems faster. So this is the drift detection problem. And I would say that this is still, although there are some libraries now that help with this, this is still more of an art than a science. In particular, for high dimensional data, drift detection is, I would say, still unsolved problem. So if you have text or images, there is not really a good technique to do this right now. After, once your model is in production, we mentioned if you want to improve your model over time, it's important to collect that data and, relabel and retrain. So in the data collection phase, the tools that most companies use are, your data lake or your data warehouse. There's a couple of problems that are still pretty challenging for a lot of teams here. Maybe not super machine learning specific, but occur often in the case of machine learning is subsampling data, right? So many machine learning use cases have high traffic. And so you can't actually just store every single data point that goes through your model. So how do you decide which subset of the data that you're going to store to be maximally useful downstream? And then connecting data that you store back to the model and back to the model performance, right? So making sure that for an individual data point, okay, was this a data point that caused a problem with my model? Is this a data point? Which version of the model does this data point correspond to? And all of that sort of metadata management, I think, is still challenging for a lot of teams to get right. In cleaning and labeling, there's your labeling tools and services, Scale being sort of maybe the best known example of that. And there's an emerging category here that I would call active learning tools, Aquarium and Scale Nucleus being maybe two best known examples that help you decide which subset of your data to label. But there's a couple of big challenges here as well. I think deciding what data you should label and then what subset of your labeled data you should train on are decisions that can make a big difference in how much of your data budget you burn through to achieve the performance level that you want to achieve, but are not maybe super well understood and don't have super robust tooling around them yet. And then finally, closing the loop to retraining, I think that's still a big challenge for a lot of companies is just knowing when you should retrain, right? This is kind of a funny one because it's such an easy question to answer in the abstract, right? You should retrain your model when the expected benefit is larger than the cost of retraining. But in practice, it turns out it's really tricky to measure the former quantity there. And so this is still a big problem for a lot of companies. So that was kind of like a whirlwind tour of what's happening in the machine learning infrastructure, machine learning tooling world, as it relates to this kind of new way of building machine learning systems that I think is critical if you want to build production machine learning systems, like machine learning enabled products and services. A few takeaways that I have from looking at this. One is there's just a lot here, right? There's many tools that are emerging to help address sort of various problems throughout the machine learning product engineering lifecycle. And that by itself is a problem, right? Because how do you decide which tools you should use? If you're using 4 or 5 tools, how do you think about gluing them together? How do you make sure that they're all working nicely together? But just because there's a lot of tools doesn't mean that every single problem is being addressed. And I think where we identified most problems were in a couple of places. One was kind of at the boundaries between these different tools, right? So especially data kind of needs to be shepherded throughout this process, from training to evaluation to collecting new data in production and then deciding what to do with those data points. And tools kind of on the borderline, or problems on the borderline between these tools are still really challenging. And then a second observation about some of the problems that we identified here is that at each of the stages of the model development lifecycle, so offline model evaluation before you deploy, running an A/B test or doing kind of an online test of your model, monitoring, deciding what data to collect, deciding what data to label. The way that you should think about making those operational decisions is by grounding yourself in a very granular understanding of how well the model is really performing at this stage. And at each of those stages, that granular understanding is lacking. And so that's really the motivation for what I think could be a tool that could help make a lot of this process a lot easier. And the way that the way I would describe the tool is called the evaluation store. And so what is an evaluation store? It's a central place where you can store and query model quality metrics. And these model quality metrics are both online and offline. So both in your kind of offline evaluation process and in your online monitoring and data collection process. And the metrics that we're looking at are both ground truth metrics like accuracy and also approximate model performance metrics. What do I mean by approximate model performance metrics? Well, it's any sort of proxy for how well your model is doing in the absence of labels. So things like data drift are an approximate model quality metric, or things like business metrics that are loosely correlated to model performance would be an approximate model quality metric. So let's make this a little more concrete. I want to talk about what are the things that you put in the evaluation store, and then what do you query out of it. At the training phase, what you put in the evaluation store is profiles of the data and the predictions that are going into your model during training. Then when you're evaluating the model that you trained, what you'll put into the model is your definitions of the metrics and slices that you want to evaluate the model on. So what are all the metrics that I care about? And then how do I want to break down those metrics along my data set? So what are the slices of data that I want to look at the metrics along? And feedback on the model's predictions. So in the offline world, most of the time, this is labels, but it could be other things as well. Then when the model's in production, what you put into the evaluation store is, again, profiles of the data that's going through the model in production. So you can catch problems in the distribution of that data as quickly as possible. And also feedback on the predictions that the model is making. So if you have a labeling service, it's the labels that the labeling service is producing. If you have business metrics that you're trying to drive, it would be those business metrics. If your users are interacting directly with your model, it might be something like, did the user click on your recommendation or not? But those feedback events are also being piped into the store. And then the evaluation store, just to kind of clarify the relationship between some of the other tools that you might already have, is not meant to be a place to store features or to store models, but would point back to those things so that you can associate an individual prediction with the version of the model and maybe the version of the feature that was used to produce it. Okay, so that's what goes into the evaluation store. Next, let's talk about what you can query out of it. So what form do queries take? So you'll ask for one or more models in the store, one or more of the metrics that we're evaluating for those models, one or more of the slices of data that we want to evaluate those metrics along, and then some way of specifying the window of data. So for example, you might ask, what is the importance weighted average drift, right? So an approximate performance metric across all of my features in my production model in the last 60 minutes, right? So it's kind of a monitoring query. Or you might ask, like, okay, for all the metrics I've defined, how do those compare between these two versions of the model across all the slices in my main evaluation set? So this is like a testing query. This is maybe the query that you would run before you decide to promote the model into production. But you could also ask things like, how do my business metrics compare for model A and model B in the last 60 minutes? So kind of an A/B testing query. quick digression to talk about approximate performance metrics. I kind of alluded to this earlier, but I think one of the core challenges of evaluating model performance online is that in a perfect world and in the academic world, we typically have access right away to ground truth labels for all of our data points in real time. And in the real world, that's just not the case. So approximate performance metrics are ways to guess at which data points might have poor performance. And these are some of the examples that I think people should be looking at in the absence of labels. So the next thing I want to do is connect the evaluation store back to the model development lifecycle that we talked about earlier, and just kind of give examples of how you might use the evaluation store in each of these stages. So at training time, what you'll put into the evaluation store is you'll register the data distribution and the performance of the model that you're training. But what the evaluation store could help you with is to warn you if your training data looks too different than production, right? That might be intentional, but it might also be caused by a bug in how you're doing pre-processing or something like that you'd want to know about before you go too far down the process of evaluating that model. At testing time, what you'll put into the evaluation store is performance. So performance of your model on all of the slices of your test data. But what the evaluation store can help you with is for pulling interesting data and slice definitions that are the inputs to your evaluation process. So if, for example, there's a data point that you see in production, or a window of data points that is anomalous or really gives your model performance problems, you might want to flag those data points so that they can be used for a future testing run. And then also, evaluation store is kind of a single source of truth for slice definitions. So that's where you pull those from. At deployment time, so when your model is in production, you'll want to log the data and approximate performance metrics back into the evaluation store so that you have access to your production performance. But what the store could help you with is for running a shadow test or an A/B test, right? Because this will just look like a query of the evaluation store. So looking at the difference in performance between different versions of the model. Monitoring is maybe the most straightforward application of the evaluation store. So you might want to just, let's say, fire an alert whenever approximate performance dips below some threshold on, let's say, any of our critical slices. When you're going back to this data collection process, again, we talked about one of the core problems here being what data should we even log? So one way to answer that question might be to say, well, we should log a random sample of our data, but we should upsample regions where we think the model might not be performing well, or where we're uncertain about how well the model is performing, because those might be the most informative regions to do future things with, like building new test sets or retraining your model. Similar story in the cleaning and labeling phase. You might want to look at the data or label the data that has low or uncertain approximate performance. And then finally, when it comes time to retraining your model, a way that you could make retraining decisions is to look at the approximate performance of your model and retrain when that performance dips below a certain threshold that you determine. So just to summarize quickly what I think a tool like this could help you with. The first thing I think of is an evaluation store could help you reduce organizational friction. So one of the things that's really challenging about building production machine learning systems at a lot of companies is that there's many stakeholders involved in the process. So there's the person who trained the model to begin with, the researcher or data scientist. There's the person responsible for productionizing the model. There's maybe a PM that has overall responsibility for the project. There's potentially a business stakeholder. There could be an ops team or an infrastructure team, maybe a head of data. And one of the things that's really difficult is that there isn't really a good substrate for communication across those different stakeholder groups. And in many cases, those folks are not all on the same page about how should we be evaluating these models? What does success look like? How do we decide when this model is ready to go into production? So I think one of the big benefits of a tool like this could be that, I think the way that these teams should communicate is through the lens of model performance, right? So, your PM, your researcher, your engineer, your business stakeholder, and your infrastructure team maybe should all get on the same page at the beginning of the project about, all right, how are we going to evaluate this model? And that means what metrics are we going to use and what slices of data are we going to evaluate it on? And then as the project goes on, those folks are aligned on the overall metrics, and there'll be a single place that they can all look to understand how well are we currently doing against those metrics. Second category of things I think a tool like this could really help with is in being able to just deploy models more confidently, right? So again, online, offline consistency is a huge issue in real world machine learning systems, at least in the past 5 or 10 years. And being able to evaluate, being able to be certain that the way that you're evaluating metrics and the slices of data that you're evaluating on are being evaluated consistently in the online world and the offline world, and having those evaluations be visible to all those stakeholders, I think could go a long way toward just making it easier to pull that sort of deployment trigger. Catching production bugs faster. So, if you can sort of immediately see degradations in approximate performance across any of the slices of data that you care about, and critically be able to drill down to the individual data points that maybe cause that degradation, I think this could go a long way towards helping with the challenging process of debugging machine learning models in production. I think a tool like this could also help reduce data-related costs. So again, I think the way that most teams think about collecting and labeling data is either we just collect and label everything if we have the budget for that, or maybe we randomly subsample the data that we're going to collect and label. And I think collecting and labeling data more intelligently could go a long way towards stretching that budget further. And then finally, and maybe to me, the most motivational reason for a tool like this is that I think it can help you make your models better, right? So knowing when to retrain and picking the right data to retrain on are sort of some of the most critical decisions that you need to make in order to make sure that your model performance is going up over time instead of going down over time, which is what tends to happen with machine learning models. All right, I will stop here and see if there's any questions. I would love to kind of make the rest of this a discussion if folks are up for that.
Mm-hmm. Yes, thank you, Josh. Just want to remind that if you want to ask a question in the live chat, there is a pinned link that you can use. You can just click on this and ask a question. In the meantime, I wanted to ask you a question about the on slide 17, you were showing how evaluation store could be used. And I wanted to ask you, yeah, this one, maybe we can make it a bit more concrete. Like you have this diagram, it was slide 17, if I'm wrong. Yeah, this one with a train and training. Yeah, so I maybe we can try to make it a bit more concrete and take an example, some project example, something simple, maybe like a click prediction or I don't know, recommender system, and show what are the things that in case we have this project, what are the things we would put in the evaluation store.
Sure.
So do you have any project in mind?
Yeah, let's say that we're training like a simple classifier. So let's say that we're classifying whether loans are going to default or not. Mm-hmm. Simple, common benchmark problem in machine learning. So when you're training the model, what you do is you have some distribution of data and distribution of predictions that are going into that, that are produced by the trained model, that are used to train the model and produced by the trained model. And so you'd want to build like a statistical profile of those two things. So what does the data distribution going in look like? And what is the distribution of predictions that the model makes at training time? You'd want to like package those things up and store them in the evaluation store so that you can compare stuff to them later.
So we have, let's say we have this, I don't know, train.csv or whatever, like a SQL script that we used for preparing the data set. And then we would look at the data we have, look at each column and save the profile for each column in the store, right? So let's say we have a income column, and then okay, this is the characteristics of the distribution, like this is the median, this is other things, and we just put them in the store, right?
Yeah, exactly.
Okay.
Then when you're evaluating the model, you're trying to answer this question of, is this model good enough to go into production? And so you, at this point, you'd also store the labels and the kind of performance metrics of the model. So you'd, if you're measuring accuracy, whatever metric you're using to evaluate this model, you would put those numbers into the store as well, associated with the same version of the model. Then the other thing you might put into the model is, and so maybe you have like many metrics that you want to associate with the model at this stage. But the other thing that you'd put in is you'd want to put in the definitions of kind of the subsets of data that you want to look at model performance along. So maybe it's really important that your model is not biased against any particular class. So it's not biased against sort of younger loan applicants or loan applicants of a particular gender or anything like that. And so you might define those things as slices so that whenever you evaluate your model, you get a report that shows you not only my accuracy, F1 score, whatever other metrics I'm looking at in aggregate across the data set, but actually broken down across all of those kind of subsets of your data that you've defined.
And these are the slices, because I think you mentioned the word slice a couple of times, like critical slices, slice definition. So this would be a particular, let's say, profile of an applicant, right? So let's say age, certain income group, that would be a slice definition, right? So for this certain profile of an applicant, we want to see that the model performance doesn't deviate too much from the overall performance of the model.
That's right. Yeah. And slices can also be defined a little bit more abstractly. So a slice could also be, let's say that you have 1,000 features that are being used to make this prediction. Well, one way you could define a slice is you could write some arbitrary function of those features. Like you could actually embed those features in using another machine learning model. And then you could threshold that embedding and use that as definition of a slice. So how well does my model perform on very unlikely data points according to this embedding model that I created? So it's not, the important thing to know there is that it's not just sliced according to values of an individual feature. It can also be kind of arbitrary combinations of the features.
Should the tool help us define these slices? Like, should we be able to do this in the I don't know, UI?
I don't know. I'm not sure the answer to that. Yeah.
Yeah, because I'm trying to. What I have in mind right now is something like MLflow, that you use for tracking experiments, and MLflow usually reports, okay, this is the F1 score, this is AUC, but it doesn't do this per slice, of course. So the picture I have in my mind is something like MLflow, but with this ability to slice and dice, go deeper into some dimensions and look what is the performance there. I don't know. Do you have something like that in your mind?
Yeah, I mean, I think there's like opportunity for tooling at different levels here, right? So I think helping identify what slices you should define is also a pretty interesting category of tools. And to me, that looks a lot more like a data visualization tool, right? Like sort of like the what if tool from Google, right? Where it makes it easy for you to like define these queries, run them, and kind of see visually what happens when you define things different ways. I think another category of tools is that could help out with this kind of thing is tools like Snorkel, right? Where they help you define these slicing functions that are just like arbitrary mappings of your data. And so that could be another category of tools that helps here. Yeah.
And the last step with production?
Yeah, and then in production, you have all this data coming in, and then later in general, you have some feedback that's coming in. And so in the loan prediction case, you have some people applying for loans, and so those feature vectors are passed into your model, and a prediction is created. And then as that data comes in, you should be on the fly creating a profile of that data that is stored in the store. And then, 3 weeks later or a month later, when you find out whether that loan was approved or denied, or whether it defaulted or didn't default, or whatever your label is, then at that point, that feedback should be also put into the store. So you have this like lagging indicator of what the actual accuracy and F1 score and things of the model could be. And that's kind of what allows you to close the loop and understand, all right, how well compared to the profiles and feedback events that we stored during training and evaluation, how well is this model actually performing in production?
Yeah. So, and then you probably can also check, okay, what is the performance this week, the week after that, and then then you can see the chart of how the model is doing per day, and then if it's a downwards trend, then you should be worried, right?
Yeah, I think a downward trend should cause you to be worried, or if there's like any, maybe there's a slice that all of a sudden is doing much worse than it was doing before, or those kinds of things are sort of like the insights that you might want to pull out in production.
So as I understood from your presentation, that a tool like that doesn't exist yet. Is there something close to that? Are there some groups of tools that we can put together, maybe some open source tool or not open source tool that we can already use, let's say now, today, if we see, okay, this is really a problem, we want to have something like that right now in our company. So how would we go about that?
So I think the closest tool to this is the TFX data validation module. So the components that this has is it has a way of like building profiles of your training data. And then it also has ways of like comparing those profiles to the data that's coming in to your model in production. I think the thing, and so I think that's a large portion of the way there. The thing that's really missing here is a couple of things. So one is actually connecting this back to feedback. So I don't think that there's a way in the system to, incorporate the labels that happen after the fact into the system. And I don't know how robust the support is for slicing, but in terms of like just, capturing these profiles and seeing how the profiles compare between training and production, I think this tool does a large part of the job.
And is it, I know that I haven't used TFX really extensively. Is it something that we can just take and use, or it's more like, because I know Google is famous for writing papers that say, this is how we do it, but you figure out how to implement this.
It is open source. Yeah.
Okay.
I think it's a little bit tightly coupled with, the TensorFlow ecosystem, the Google Cloud ecosystem. So I think if you're running TensorFlow on Google Cloud, it's probably pretty easy to use something like this. If you're using, PyTorch on AWS, maybe not so much. But yeah. And then I think also the other thing I'd mention is that the company that I started not too long ago is working on a tool that we think does all of this. And so if we haven't released it yet, but if folks are interested, then you should come get in touch and talk to us about it.
Yeah, that's why your LinkedIn profile says stealth startup, right? And that's why you're saying you're presenting this thing, right? I figured there must be some connection.
Because I think it can help, because I care about this field, and I want there to be more models in production. I want machine learning to fulfill its promise, but that's also the reason why I'm building a tool to help with it. So,
yeah, thanks. Yeah, we have a question from Saurabh. So his question is how we can use Feature Store, Model Hub, and Evaluation Store. Well, I guess Evaluation Store doesn't really exist, but if there is a close alternative like TFX, how can we use these things in personal projects? Would it be an overkill? Like, let's say if we're not doing this for a company that is running things on large scale.
I think I think feature stores and model hubs are definitely overkill for a personal project. I think probably, well, I think the things that the components of the evaluation store that might be helpful for a personal project, I think like a system like TFX data validation is probably overkill for a personal project as well. But the things that you might want to have are if you're retraining models, you might want to know, you might want to understand how the data distribution that you're retraining on is evolving over time. And then the second thing they might want to have is you might want to have some way of closing the data flywheel, right? So you might want to be able to collect the data that's going through your model when you deploy it, assuming that you're deploying it as part of your personal project, and then being able to use that for future retrainings. And so I don't think that there's really a great tool that you can just grab off the shelf to do those things right now. And so maybe, if the evaluation store is the implementation of the evaluation store is lightweight enough, then it might be useful for solving those problems in a personal project. But I wouldn't, if I were working on a personal project, I wouldn't touch feature stores or model hubs. Those are tools that I think make sense when you are really, really valuable when you know that you need them when you're at scale.
Yeah, there is a related question from Mert is how to actually learn these tools when you're a student yet, so when you don't work yet. And so I understand that on one hand, this is actually an overkill. So I also wouldn't use such tools, such things for a personal project. But on the other hand, if you're an aspiring, I don't know, machine learning engineer, and you want to show your potential employer that I already know these tools, I know why they are needed, I know how to use them, this could give a competitive edge. So do you agree with that? And if yes, like how would you suggest to approach learning these
maybe,
tools?
but I think that I would focus more on learning the fundamentals while you're still a student. I think learning the fundamentals of like data systems and data infrastructure, learning the fundamentals of machine learning, those things are things that are very possible to learn while you're a student or while you're still in kind of education phase. And you can learn about the rest of the tooling ecosystem at a higher level. Like you should learn about what the tools do and how they fit together and things like that. But I think there's just some tools that are extremely difficult to get experience with, except at scale. And this is not just true in machine learning. And I think that I would argue that your time is better spent learning the things that are well suited to learn in an academic environment, and then learning these other things on the job.
So, okay, thank you. And some of these things, you can still get some exposure to these tools because I think this is what you teach at the full stack deep learning course, right?
Yeah.
So what kind of tools do you cover there? What kind of techniques when it comes to model deployment and all this production stuff?
Yeah, so we cover like pretty simple tools there because the kind of the kind of production use case that we're focused on is, okay, you're working on a production model by yourself or as part of a small team. So what could your tooling stack look like there? And so we package up models in Docker containers and deploy them using AWS Lambda, which is a perfectly reasonable way to do things at a relatively small scale. If you're working at Google or Facebook or another massive company, it's not going to be the way that you do things. But in some sense, it doesn't make sense to try to learn the tools for scale until you are working on problems at scale, because you won't run into the challenges that those tools were designed to address until you have like the volume of data that you need in order to run into those problems. And it's very hard to reproduce that in a toy environment.
Yeah, thank you. I also have another question that is not strictly related to, well, maybe it is to evaluation store, but when you were showing this process for training, like just for approaching a machine learning project, yeah, this one exactly. So one thing, yeah, so here, so in the test phase, so one thing that I wanted to ask you is, so this, I guess it's more about model debugging, trying to understand, okay, my model is wrong, why, right?
Well,
Or
so yeah, go ahead. Yeah.
Yeah, I guess it's not just that. You mentioned many things there, but so I have maybe two questions here. Is model debugging a part of that? And the second is, yeah, maybe let's first do the first one. So, is it?
Yeah. So the way I kind of define the gap between training and testing is when you're in this like, so when you're training models, you're also evaluating them, right? But the way I typically recommend that people evaluate their models when you're in this iterative kind of constantly retraining phase is at most of the time you should be really focused on a single performance metric, driving that number up or driving it down. And in the real world, we care about many metrics, and so that means you need to choose one metric to focus on at any given time when you're in this like training and evaluation phase. And then where that phase ends is when your performance according to that metric, or really according to like maybe all the metrics that you care about, is below a certain threshold that you've set in advance as part of the project. And then you should be reasonably confident that your model is bug free, and you should be reasonably confident that its aggregate performance is good. Then you move into the testing phase, right? So then you have like a candidate model. That this is a model you're thinking about deploying into production because your validation score is below your validation score threshold. Then what the testing phase is about is it's about two things, right? So one is like building a more granular understanding of how well this model really performs across all the slices of data that you care about, all the metrics that you care about, not just that single number. In comparison to maybe an old version of your model, in comparison to like whatever sort of like criteria that you've defined as part of the problem definition phase of your project. So that's kind of the first goal. Is like let's really understand how well this model is performing before we deploy it. And then the second goal is to build sort of a model of the performance envelope of this model. And what I mean by that is like where should you not expect the model to perform well? Because that's information that's going to be important for figuring out later when the model is not performing well. So are there certain regions of space where where model performance is bad? Like what does typical training or evaluation data look like, so we can detect things that are anomalous to that. And so those are sort of the two goals of the evaluation phase, right? Like more granular understanding of model performance, and then understanding of the performance envelope of the model, so that we can detect things that don't look like what we know the model performs well on.
Okay, if we talk again about the example we had about default prediction, so let's say we want to train a model. So we experiment with feature engineering. We try different models like XGBoost, LightGBM, whatever. We tune parameters, and then there is one metric we want to optimize. Let's say F1 score, right? So we do all that. We look at thousands of models, and then we come up with one good one that we think is good. And it all happens in the training phase, right? So we have this one good model, and then we go to the test phase. So in the test phase, we have some ground truth data set. And what we do next is we apply this model candidate to this test set, and we evaluate it at different slices. We look at all these things you mentioned, right? Like, is there some slice of the data where the model doesn't perform well? We also look at other metrics. We also try to understand how the business metrics will look like, things like this, right?
Yeah.
Am I right?
Exactly. Mm-hmm.
Okay. And then you also mentioned CI/CD here in test. And how is it related? So I guess this is you do as a part of your pipeline. So you say, okay, I want to promote this model as a good candidate, and then something happens, and then CI/CD pipeline is triggered, and all this evaluation happens, or?
Yeah, so these don't necessarily need to be linked, but I think a good practice is to have the testing phase be automated as part of your CI/CD pipeline. So when you're done with your experimentation, you have a candidate model, you create a pull request, right, to merge that new model into your story models, whatever path you have to promoting that model's production. And then as part of that pull request, you should be looking at a report that says, or maybe a tool, like an inspection tool, but some way of sort of understanding these questions, right? Like granular performance of the model. And that should be one of the stage gates that you have to pass through in order to promote that model into production. And so that's where CI/CD is relevant.
Okay. So the output of this thing could be some report on different slices, and then it's up to a human to decide if this model should go to production or not. And in CI/CD, it could be just I don't know, this clicking on one of the steps, saying, okay, go ahead.
I think so. Yeah, yeah. You could try to automate this as well, but I think I would probably, on my machine learning team, we would be looking at it manually. Put it that way. Because I think it's pretty subtle to automate it if you are not just looking at a single metric. Because what happens if if your model performance goes down in aggregate but goes up a little bit on one critical slice? Is that bad? Is that good? Yeah.
Yeah, thank you. Then another question I had related to testing is about test-driven development, which is like this is what usually software engineering teams have. But in my experience, it doesn't really fit well in machine learning paradigm because like while in traditional software engineering, for the same input, you always have the same output, but with machine learning, it's a bit different. Yet we still try to find a way to have the safety net that we have with tests in software engineering. So what kind of tests we can have that are similar to, let's say, unit tests in software engineering that we can still use in machine learning?
Yeah, I think I'll give a short answer to this, and then for a longer answer, we have a whole lecture on this in the
cool.
deep learning class. But I mean, I think at a high level, I think the most important types of tests to have for machine learning systems are basically like data sets that correspond to like certain performance characteristics that you want your model to have. So for example, if you have like a million examples in your validation set, that's one thing to look at, but you might also want to look at have like smaller data sets that correspond to like particular subsets of your data that have given your model performance problems in the past, or where it would be really bad if the model performs badly on this data set, or things like that. And so I think that like the most important type of data sets, the most important types of tests to have is like all of these like kind of smaller data sets that help you identify in a more sort of robust way that the model has all the performance characteristics that we want it to have.
Thank you. Well, one last question. It's relatively short from George. Is it advisable to be looking at learning how to deploy models in cloud at early stages of a learning journey? So let's say it's related to the question we had previously a few questions ago, like how do you go about learning all these tools? And I think the question is related, like, is it advisable to learn the cloud providers while you're learning, not at work?
Yeah, I think it can be useful to learn those things early. We teach about these things in our course, especially because one of the best ways to learn is to do projects that are related to the thing that you're trying to learn. And so being able to deploy your models as part of the project makes the project a lot more fun and a lot more interesting. But I would say my overall advice on learning stuff is focus on the fundamentals first, right? When you have a good understanding of sort of databases and data systems and machine learning fundamentals, then it's the things like deployment and stuff like that are easier to learn on the job, or when you already have a system that you want to deploy. And so I would focus on like learning the hard things first and then picking up the rest as you go.
Yeah, thank you. One last question: how can people find you?
Find me on Twitter. It's probably the easiest way.
Josh_Tobin_.
That's right. Yeah.
Well, I guess that's it. Thanks a lot for joining us today and sharing your experience, your knowledge with us, and also thinking about this great tool that we can have. Hopefully, we will see something soon.
Hopefully soon.
So keep us posted, and of course, to know when about the development. So we should follow you on Twitter, right?
That's right. Yeah.
Okay, that's the best way to stay up to date with developments, with development in this area about evaluation stores, right?
I think that's right, yeah.
Thanks a lot. Thanks for waking up so early to have this chat with us.
Yeah, thanks so much. This was fun. And yeah, hope everyone has a good evening, I guess.
Yes, well, or morning, because I think
or wherever you are in the world.
yes, or night, or yeah. Well, have a great day, Josh, and thanks everyone for joining the session today. And see you on Friday.
Thanks, everyone.
Goodbye.